This meeting is being recorded.
All right, greetings to everyone. So we are from session 2. And today I'm Triating, and today I'm doing the assembly demo on the benchmarking projects. So you can see in our code, this is the data segment. So the val y abcd is for the calculation of the polynomial computations. And this one is to manipulate the each loop count. And these three variables are to find the execution time of the assembly benchmarking, and these are all a display message, which ending with zero now terminated, and some with n9. And next we talk about the code segment. So in our code, we consist of two loops. One is the main loop, and the main loop is mainly manipulated by when the user press yes or no. And the inner loop is manipulated by the loop entered by the users. So in each loop, we call the clear screen first, and then we display the message. And this one is a prompt to call the write that. Read that. And then because read that will store result in ES, right? So we want to have our loop count in the ES also. So and we call the write string again by moving EDX. And then at every loops, we will initialize the ESI, which is acting as our S value, to be 1, because it is starting with 1, right? And then the EBS, so the EBS in register in our code will be acting as a accumulator of the results. So it will store every Y result computed by the each loops. And then this one is to get the starting time by calling the get ms seconds. And yeah, you also store the result in ES, so we move the ES into the start time, and then we can finally start the loops. So in we will move the val A into ES because code delay will detect the EAS value to determine how much delay will compute. So val A is our delay coefficient, and then we call delay, and then we're gonna compute AS cube, right? So uh I will multiply the ES by ESI, which is the S value, by 3 times. So now our ES have the AS cube values, and then you move you will add the EAS into EBS, so it's an accumulator of a result. So again, we call val B as a delay coefficients, and then we get ds squared by multiplying by 2 times, and then we add the results val c, and then co-delay again, and then we multiply by 1 time to get the cs, and then add it, and then we move the val d into the es, and then co-delay again, and then we add the ebs to the es to the ebs, so we get the as cubed plus bs plus cs plus d each y, and then we increment the ESI by 1 each loop. So we will compare the ESI with the loop count, which is maybe 50 or 100 or 1000 with the ESI. So if it's less than or equal, it goes back to the L1 to compute the polynomial computations. Else, it will break the loop. Let's say the loop is 50, and then once it ESI reach 51, you break the loop. And then after the loop, we're gonna call the get ms seconds to get the ending time. And then by subtracting the ES by the starting time, we can get the elapsed time of the execution time of the whole program. And then val y, and then the core write string, these are all for prompting. And then we're gonna write every results here. So include the execution time, starting time, ending time, and then also the final results. And then it in the final ending loops, we're gonna ask the user to continue the execution of the benchmark or not. So it will read char. So if the input is y, we'll compare the AL. Why compare AL? It's because read char will will store result at AL. So we straight away compare AL with y. So you compare the S key value, and then if it's equal, you carry the flag of equal into the JE main loop. So if equal, it goes back to the main loop. Else it goes as it, and that's all for our program. And I'll start the demo right now. Very well. Oh wait. Always remember to off it first. And yeah, for example, in this code, I actually, because for the accuracy of benchmarking, I already restart the computer before it. So let's enter 50 first. Okay, record the results. Press yes. 100. So different loop basically means different workloads. So yeah, record the results. Yes. 200. So you can see in each loop, we'll have a different execution time, and we're going to record and compare with each computers. So 500. Okay, record the results. Press yes. 700. So different looping actually simulates a different workload to the computer. So we are going to see is there any short-swing effects, or there's a significant drop in performance once the workload is high. It's like we want to see the computer can withstand the workload or not, or we're starting to falls apart. If the workload is very high and start to struggling to address the task given by the computers. Okay, record the result. So it's around 60 seconds. And finally, 1000 loops. Also, you notice the result contains some overflow because the Y summation could be too high. So our code actually cannot withstand cannot address the overflow of the integers, but we still can get a clear insights on the execution times, which is valuable insights to compare the performance of each computers. So let's wait the result for the final 1000 loops. All right, so we get the final result, and it should be at the end of the benchmarking. So we press N to exit the benchmarks. And that's all for our demo for the SMB benchmarking. And thank you very much.